Let's talk about end-to-end web UI testing, everybody. I'd like to introduce myself briefly. My name is Pandy. You may also know me as the Automation Panda. I am a software engineer in test. That means I help develop solutions to testing problems. I do that every day, and I love it, and that's why I'm here to tell you a little bit about it today. So please follow me on Twitter, follow my blog. I also have these rad Automation Panda stickers if anybody wants one after our talk today. Also, shameless plug, I'm an organizer for PyCarolinas. We're going to have PyCarolinas 2020 in Raleigh, North Carolina from June 20th to 21st in downtown at the Red Hat Tower. 2 days, 2 tracks, 2 keynotes, about 200 people. January 1st, 2020, CFP open. So if you're interested, go to pycarolinas.org. But back to more important things. We're not here to talk about conferences. We're here to talk about testing. And the impetus for me to give this talk today is something that's kind of bothered me a little bit. As I said, I'm a software engineer in test, and I do testing all day, every day. It's wonderful, and specifically test automation. But when people talk about testing, I've noticed that there's this undercurrent that some people think that unit testing encompasses all the testing that we need to do. And that's not simply true. There are many types of testing. There are many layers of testing. And so I want to give some treatment to those other layers. Now, I'm not crazy when I identify this misconception. The Python Developer Survey in 2018 made this mistake itself. Now, I love the Python Developer Survey. I'm not here to knock heads or complain. But when I took the survey, I noticed they had a section on testing frameworks. And I got excited. I was like, oh boy, Python and testing, this is the best thing ever. And then I go to read, and immediately they say deleting unit testing frameworks. So there was, not all testing frameworks are just for unit testing. So that kind of bugged me a little bit. And so I was like, well, okay, let's look at what it means to be above unit testing. There is a difference between testing code and testing features. I'm going to say this again. There is a big difference between testing code and testing features. What's the difference? Well, when we're testing code, we're talking about directly testing that Python source code that we write, or in whatever language that may be. It's inherently white box because we are directly interacting with the code under test. And when we do white box testing of code, the question we're asking is the code written to do the expected things? Right? If I write a function that's supposed to add 2 numbers together, is it actually doing addition? Typically, we call these unit tests. But if we do a bit larger scale than just a function or method, it could also become a subcutaneous test. On the other hand, features are the things that are built from code. Right? A feature is a built software product or artifact or part of a product. Users or some other callers are what's going to be interacting with those features. So you could think about maybe a login page or maybe a REST API. That's what we're talking about with features, those built artifacts, the things that we actually get value out of in our software. And to test features, we need to do it black box, meaning we're not directly accessing the Python code or the Java code or whatever kind of code you write. You're interacting with that feature like it's a real thing. If I need to test login, I'm going to log into my website. If I need to test a REST API, I'm going to call it and see what response I get back. So the question we're trying to answer with feature testing in a black box style is, does the product, does the feature meet the requirements for it? And so this is where we get a lot of our integration testing from, or our end-to-end testing from. So we see there's that difference. For code, we're going to use white box tests. For features, we're going to use black box tests. Both are important. I just want to point out that they are distinct. So let's talk then about web UI testing and where it falls into that. Web UI testing is inherently black box. It is a black box testing of a web application through a real live browser. With web UI testing, we're going to fire up our app or our website through, say, Chrome or Firefox or Safari, and we're going to fiddle around with it in the browser. It's feature testing because it tests the app like a user would. And it is end-to-end because all the parts of that web application are either explicitly or implicitly tested together. If you think about all the layers of a web application, it's more than just the front end. The front end is what you see in your browser. But behind that, you probably have a backend, maybe some services. You probably have a persistence layer with databases. You may have workers. You may have queues. You may have a load balancer. All that stuff together, combined, is what makes your web application happen. And how people get to interact with that web application is through the browser. So by testing through a real browser, we're going to be able to effectively test our web application end to end. However, web UI testing is expensive. How many people have actually done some web UI testing before? Web UI test automation specifically? Okay, we know it can suck, right? It's not easy. There are problems with race conditions. There's a lot of extra code you need to use libraries. So it's not that it's impossible, and it's not that it's not worthwhile, but rather it's expensive. And so with that, we want to make sure that we're focusing our efforts on good return on investment for the time we put in. So whereas it's very easy and quick to write a bunch of unit tests, we may not want to write as many web UI tests. We definitely want to make sure we have unit tests and integration tests covering lower layers, so we don't need to check things like basic string formatting of dates through the browser. Rather, web UI testing should focus on bigger things like, can I log in? What happens when I go to this page? What happens if I try to upload a new profile picture? What happens if I search? So focus on typically like happy paths, focus on return on investment, that you're actually testing things that matter to your users so that you're not wasting time unnecessarily. So we know it can be hard. What I'm here to do today is to show with Python, it can actually be made a little bit easier. What we're going to do is we're going to put together a very small test solution using these parts. We're going to write a simple test for the DuckDuckGo search engine, and we're going to go top to bottom with it so you can see all the layers and how they come together. The language we're going to use is going to be Java. No, we're at a Python conference. We're using Python. The core framework we're going to use is pytest. How many people have heard of pytest? I love pytest. It's my favorite Python library. It's wonderful. I have opinions about it. It's good. I love pytest. OK, so for UI interactions, when I say UI interactions, that's modeling the interactions with the browser under test. We're going to use something called page object pattern to model that, and we'll see why. And then finally, for the actual browser automation, the mechanics of sending out commands and sending clicks and scraping, we're going to use Selenium WebDriver, which is like the de facto tool for doing this kind of stuff. And I'm going to show you how with Python it can be concise and tight and nice and easy. This is how all these parts work together. Ultimately, we're going to write a series of pytest tests. Today, in here, we're only going to write one. Why? Because I only have 25 minutes. But in theory, you would have more tests. The tests themselves we'll be calling page object classes. We're going to make a page object or two on the way. And it's inside those page objects that you make your direct Selenium WebDriver calls. The WebDriver calls will then go to what we call a WebDriver executable. It's a thing that you stick on your machine. It will then, with the WebDriver executable, act as a proxy between your test automation and the browser itself so that it can send the commands to the browser to do your clicks, your text scrapes, all that kind of stuff. If you want to do something more scaled out, you can also use Selenium Grid or a service like Sauce Labs or cross-browser testing, but we're not going to get into that today. The key thing I want everyone to understand is that you have your tests, calling page objects, calling Selenium to your little WebDriver executable that depends on the browser, then manipulates the browser directly. This is all fairly boilerplate for Selenium WebDriver. So let's write a basic web test together. I always recommend, especially when doing feature testing, you identify and write down your test steps before you write your test code. A lot of times, the big mistake people make is they go directly into Selenium code and they start trying to crank out stuff, and it turns out like crap. You always have to ask, why are we testing this? What are we doing? I like to identify my test steps and then put them in code, and we'll see how that goes. So, as I said, we're going to write a test for DuckDuckGo. This is just like any other search engine, like Google or Bing or Yahoo. I'm sure everybody's familiar with search engines. Yeah, cool. So let's write a test together. I want to write a basic search test. Step one, what do we have to do? We have to navigate to the DuckDuckGo homepage. Don't overlook that step. It's got to be done. Then what do? Step 2, we enter in our search phrase. I'm going to use the search phrase panda for obvious reasons. Not only do we have to enter the text, but we also have to commit the search, either by hitting the enter key or by hitting that little hourglass search button. Third, we're going to wait for that page to load, and then I want to verify some things, because I need to check on things to make sure that my test was correct. Or not that the test was correct, but that the feature is correct and working as designed. So one of the things I want to check for, I want to verify that the query appears in the title at the top of the page. I also want to check that the search phrase is in that new search box. The search box is moved because we're now on the results page. I want to make sure that's there. And finally, one of the trickier tests, I want to make sure that all of the links somehow relate to my search phrase, being panda. So I want to scrape these links and just check that, okay, we've got our search phrase in there in some form or other. Does this test make sense? Seems fairly doable, seems fairly straightforward. Great. So now that we understand what our test steps are, let's take them and put them into pytest, our test framework. So a lot of hands were raised with pytest. I don't need to talk about it too much. Pytest helps you write better programs. I love pytest. It's a very simple, very Pythonic test framework. Instead of writing classes, you write functions. If you want to learn more, I highly recommend their documentation site. It's beautiful. And up here is just a screenshot from their homepage. And this is an example of what a pytest test looks like. Test underscore answer, assert, some call equals some value. Our test will be a little bit more complex than that. But just to give an idea with how we use pytest, you just make test functions and roll with it. If the documentation sites don't cut it, I recommend these two books on pytest, Python Testing with pytest by Brian Ocken and PyTest Quick Start Guide by Bruno Oliveira. Both of these, I've read them. They're excellent. To install pytest, you just do a pip install. Boom, and it's in your project. Now that we have pytest up and going, what we'll do is in our project directory, we should create a folder called tests. And then in that folder, we should create a Python module called test_search.py. In this test module, I'm going to make a test function. Test_basic DuckDuckGo search. And what I'm going to do initially is I'm just going to write my test steps in comments. This test will basically do nothing. I'll also put an exception, a hard-coded exception here at the bottom to show that this test is incomplete. Now you may think, this is kind of dumb. Why am I doing this? Because we write our test steps before we write our test code. And my test steps are going to be my guidelines, excuse me, as I go to automate this test case. Hence the to-do tags and comments as well. What's nice about this setup, if you put it in a test folder with a test name module and a test function, when you go to run pytest, it will automatically discover all the tests within the structure and run them one at a time. That's why the naming is a bit important here. So now that we know what our test steps are, let's look at actually automating those interactions. The tool we have to use is called Selenium WebDriver. It's a free and open source project. It's the de facto way that we do browser and web UI automation. There are bindings in all the major languages, including Python. Project's been around for, gosh, a decade at least. So it's fairly well established. WebDriver itself is a W3C standard. So Selenium WebDriver is just an implementation of that standard. All major browsers support this standard as well, hence we can do the interactions. And how it works, like we saw earlier, is we will make Python calls to Selenium WebDriver that will then go to the browser and come back. What's really nice is that Selenium WebDriver can handle any type of web UI interaction, whether that's clicking a button, doing a drop down on a select, hitting radio buttons, scraping text, entering things into input fields. It's all supported. If you as a human can do it in the browser, Selenium can do it too. And there's also something called Appium, which is for mobile applications. Now, we don't want to make our calls directly from the test case to Selenium WebDriver. What we want to do is we want to have an interaction layer in between. And that's where our page objects come from. Yes. So we'll get to page objects a little bit later. But I want to call that out now. You always want to have that interaction layer because otherwise you'll find yourself making tons of redundant Selenium WebDriver calls repeatedly. So there's plenty of documentation on the internet for Selenium WebDriver. This is the Read the Docs page on the WebDriver API. If you're not sure what a method should be or if it has a method for what you want to do, come to this page, you'll find it. How do you install Selenium? Pip install Selenium, just like pytest. In order to use Selenium WebDriver, we need to initialize it for our tests. Now, since we're using pytest, I'm going to use a pytest fixture for initializing my WebDriver. What I have to do is, first of all, I'm going to create a module in my test directory called conftest.py. It's usually a best practice to put all of your shared fixtures in a conftest.py file for pytest. And then I'm going to define a function with the pytest fixture decorator to say, hey, this is my fixture. Now, if you're not familiar with pytest fixtures, it's just a fancy way of saying a setup and a cleanup. Whereas in the unit test framework, you'll have setup and cleanup methods as part of your test class. With pytest, your fixture basically acts as a setup and also a cleanup function. And we're going to see later how that will get dependency injected into the test cases. So I've got my conftest.py file. I've got my fixture method here. And here's what we're going to do to set up Selenium WebDriver. This will be for local testing, meaning whatever machine is running pytest test is also going to have the browser running on it. Of course, as prerequisites, you will need the browser installed on the machine. So if you're testing Chrome, your machine better have Chrome. You will also need the appropriate WebDriver executable for that machine. So if I'm using Chrome, I need to install Chrome driver and put it on the system path. For Firefox, it's Gecko driver. For Internet Explorer, it's IE driver. And I think, I'm not sure, but I think with Safari, it's actually built into the browser. So that, as we recall, will act as the proxy between our test automation code and our browser. When we initialize, the bindings will start that executable as well as the browser. So to do the initialization, that's the first line of code here, Selenium WebDriver.chrome. That initializes the WebDriver. It looks for Chrome driver on your system path. We'll initialize that process, which will then open up Chrome as the browser. And if you're running it locally, you'll actually see Chrome open up. Pretty cool stuff. Now we need to store that object reference because we're going to use it later. Next thing we're going to do is we're going to set an implicit timeout. The big problem with web UI testing is race conditions, right? You have a website that is doing stuff on its own. And when you trigger interactions on it, it needs to go and think about it. It needs to wait for the page to load. It needs to wait for the DOM to change, right? That process is going to be spinning over here. But at the same time, your test automation system is still going to be running. So what happens if you try to then interact with an element before the page has loaded it? It'll blow up. Bad. Race condition. Do not want. So what we want to do is we want to have WebDriver implicitly wait automatically until elements appear on the page before trying to interact with them. Now, this is a very rudimentary kind of wait. It's simple. It's a little bit hacky. I could spend a whole nother talk talking about implicit versus explicit waits. But for the purposes of this small solution, this is going to be fine. But I encourage you to look up explicit waits as well as implicit waits to make your solution better. So after we've initialized the WebDriver and we've set the waiting time, we're going to yield a reference to that driver. Now, you may think that's kind of weird. Why am I yielding? Why am I not returning? With pytest fixtures, if you return, it will only be a setup fixture. But if you yield, your fixture becomes both setup and cleanup. So by yielding here, I'm saying my setup portion of this fixture is that I have initialized my WebDriver. It's up and ready for testing. Here's a reference to it so tests can use it. And then sit back and wait for the test to finish. Once the test is finished, pytest will then automatically come back in here because this yield makes this function a generator. And so the second iteration of the generation will be to quit the WebDriver. Right? I want to make sure when my test is done, I close down Chrome or Firefox or Safari or whatever. If you don't quit your WebDriver, you might have zombies. Right? And what do zombies do? They bring down your continuous integration system. So always quit your driver no matter what. Pro tip. True story. Cool, cool. So now that we have Selenium WebDriver initialized, let's talk about page objects. So a page object is an object representing a web page or components. It has two parts. It has locators for finding elements, and it has interaction methods for doing those interactions. That's what's going to encapsulate all those clicks, all that login, all that scraping, all that good stuff. For our simple test, we need two page objects. We need one for the search page, and we need one for the results page. So here is an example implementation of what our search page could be. Typically, I recommend create a Python create a Python package called pages, put your init.py in there, and then each page object should be a separate Python module. And you could do hierarchy as you like. So my search page here, this is just a very basic implementation. There's multiple ways to do this. This is just a simple way I chose to do it. As you'll see in my search page, my init method is going to take in a reference to a browser, the WebDriver. That's going to come from the fixture, which is going to be passed into the test case, and then here. All this is to say is dependency injection coming in for the page should be some WebDriver reference. I've got two methods on my search page, one of which is going to load the page. That's browser.get for my URL, DuckDuckGo.com. And the other one is going to do a search for a particular phrase that's passed in. So I'm going to say self.browser, find elements using my search input element locator. Search input comes from the same class. It's a locator that looks up something by the name of Q. That's going to represent the search element on the home page. Then, once I have the search element, I'm going to send the keys for my phrase plus the enter key. So that's how I can use page objects to model my interactions. Now, locators are a bit tricky. I could spend an entire tutorial's worth on how to write good locators. Typically, when I try to find locators, I will go use Chrome DevTools, right-click into its inspect, and then I'll hover and look for the elements that I want to target. And from those elements, I'll try to find the locators from there. So given that this is my search input element, it's a little hard to see here, but there is a name attribute named Q. If you want to learn more about locators, I recommend going to Test Automation University and taking the Web Element Locator Strategies course. It's free, it's got video, it's got example code. Highly recommended if you want to do this more. So finally, let's pull all the pieces together. Now that I have my page objects and my WebDriver, how do I implement my test? Well, first of all, in my search test, I can create the page objects. The browser is the name of the fixture. So when this test runs, it's going to call the fixture first and pass it in as that reference variable. And I'm going to inject that directly into the page objects. Each of my steps that we had before, we're going to implement with page object calls. I'm going to keep the comment line because it's fairly helpful. But then you can see it's still pretty obvious. Given the DuckDuckGo homepage is displayed, I'm going to say searchpage.load. When the user searches for panda, searchpage.search panda. Then the search result title contains panda. Now, I haven't shown you this page object, but we could have a result page object that has a title method, or one that has a search input value method, or one that will give you the list of result link titles, and you make sure that your phrase is in all the lowercase versions of those titles. So that's how we can automate that test. So I know this is a lot of information to cover in a very, very short amount of time. If this is something you want to learn more about, I actually gave this as a tutorial at DjangoCon last week. So if you go to my GitHub account, AndyLPK247, DjangoCon 2019 Web UI testing tutorial, this can be self-guided. There's a huge README with all the instructions. You start with the basic project, and then lesson by lesson, you'll go through and implement things as you go. It's very hands-on. So I'm going to leave this resources slide up here. Take this as well. Take a picture of this as well. There's even more information as well as that tutorial. I am quickly out of time, but if you would like, I'm available for questions and stickers and to talk about PyCarolinas after this talk. So thank you all very much. I hope this was helpful.